Yeah, thank you. I'm Sophia Politt from Kiel University, and I'm going to talk about the combined archaeozoological, thank you, and isotopic analysis of faunal remains from Pniel 6 in South Africa. And yeah, I did this together with Helena Pribliczki, for example, who analyzed mostly bones while I did teeth. And yeah, first of all, I want to introduce the site to you, then talk about carbon and oxygen isotopes results, the results of our species classification, the taxonomy, and finally all this together leading to environmental reconstruction at the site. So, sorry. It's not working.
Maybe use the arrows.
Yeah, I already did. I'm sorry. So maybe if we click there, I don't know.
Yeah.
Okay, so first let me introduce our site. Marked with a red arrow. We are at South Africa in the Northern Cape, and the site Pniel 6, as you can see here, is close to the Vaal River, which you can see here, very beautiful. And it is located in summer rainfall zone in South Africa, and today there's a savanna biome. And the nice thing today is that nearly all grasses are C4 grasses, and all other plants with our trees, shrubs, and herbs are C3 plants. And yeah, talking about the history of the site, there have been several surveys and excavations during the time. It has been known for a long time, and the most important excavations were carried out by Peter Beaumont in the 1980s and 1990s, and by the Minerva team in 2017 to 2019. And for the finds, we have two find categories, basically, which are faunal remains, which I'm going to talk about now. And first, some lithics. They appear together in discrete packages. And yeah, we have Forest-Smith lithics made of hornfelds. And because they are so closely linked, we can make environment reconstructions for the humans that lived there. So the dating is a little bit complicated. We are at the transition period between the early Stone Age and Middle Stone Age here, as I already said, with the Forest-Smith industry. And we are in the Floresian land mammal age, which is also the time when Homo sapiens first appears in South Africa. And we have one date of intracrystalline protein degradation analysis of animal, which yielded an age older than 151 Ka. So now to my material methods. We looked at animal teeth and bones from Beaumont's excavations and the Minerva project. And all in all, we looked at 318 teeth and 202 bones. And we took also 65 isotope samples from the teeth for carbon and oxygen isotopes. And we also used these samples for an FTIR analysis. And yeah, First of all, we did a species classification using the comparative collection at Florisbad with extinct and modern animals. And yeah, we calculated the NISP numbers for the bones and teeth. And then, of course, you all know how this works, but for the stable carbon and oxygen isotope analysis, we took double measurements. And yeah, just as a quality control, actually. And when there was a deviation larger than 1 per mil in these double measurements, we excluded the samples. So we only included samples of good quality. And for the FTIR analysis, we used the same ATR, FTIR Carolina already introduced. And yeah, this, by exciting molecules with infrared light, we get this nice spectra, and we also can calculate some preservation parameters, and this we used as a quality control also, and compared it to the double measurements. So now to the results of our species classifications. We had 172 specimens that we could identify on species level, and some more we could identify on genus level. And as you can see, there are really many archaeozoological. This is only the first part of the chart because it was so large. And yeah, we have some species that tell us special things about the environment. We have a black wildebeest, which is known to need an open habitat. And here we also have an extinct species, which is a large giant archaeozoological, and this is a typical species for the Floresian land mammal age. And on part 2 of our chart, we also have many equids over there, and also many hippos, actually. And these are, as we all know, quite water dependent, as well as the water bug and the ledgewort, which we also have. And again, here are some extinct species, which are the Bond's springbok and the Cape zebra, which are also typical for the Floresian land mammal age. Now to the taphonomic analysis, which was carried out by Helena Pribliczki. We have some bones with traces of burning, but there are only 2, as one of them you can see here in the middle. And then we have some bones with percussion marks, or possible percussion marks. This one, as you can see here, that's maybe a percussion mark on this bone. And we have also some possible tools, like this really elongated bone, for example. We don't really know if there are tools, but maybe. And all in all, we have only few altered bones, actually, and we can also, by gnawing marks, we can see an impact of humans and carnivores in our sample. And all in all, the human impact is not big, but it is there. And now to our stable isotope analysis. Just to introduce you to this diagram. These are the means of the double measurements for every individual, except for the ones with the black line, black circle around them. Those are single measurements where we couldn't take double measurements. And the red lines are only here to show the differences between C3, C4 and C3 and C4 feeders in the isotope, in the carbon isotopes. And maybe to have a closer look, the species means are a little bit, more compact to look at. And about the species, we have one typical browsing species, which is the eland, which falls well into the C3 values, which is quite nice. And nearly all other species are grazers today, except for the springbok, which is a mixed feeder. It works, okay. So this springbok, as you can see here, is a mixed feeder. As you can see, most animals at that time at Pniel had a diet of mixed C3 and C4 plants, and the second most animals had a pure C4 diet, and only the eland had a C3 diet. And because most of these species are grazers, we think that there were probably more C3 grasses in the region than there are today. As I already told you today, there are with some, mostly C4 grasses in the region. And then, this could probably mean that we had some climatic differences, that it was cooler and wetter. And for the oxygen, it is a little bit harder to interpret, actually. And what is very nice is that the hippo is really different from all other species, because, they spend most of their times in water, are very water dependent. But some other water dependent species, which are the ledge and the water bug, are just kind of in the middle of all other species, so this is not so clear. And all of these species are obligate drinkers, but browsers normally drink a little bit less than grazers, so this could explain why the eland is also quite high in oxygen, but still, for example, the plain zebra is higher, so we don't know. It's not that clear, actually. And as you see, there's a quite large span in oxygen values, which is kind of typical for this time and region. And it seems that all in all, there was a little bit more water than today, or maybe not just a little bit. And so, at this place, I actually wanted to show you my FTIR analysis results, but sadly, it is more complicated and complex than we first thought, and we couldn't finish the analysis yet completely. So what we can say until now is that probably the FTIR analysis does not support the double measurements from the isotope. So that, as Carolina already said, maybe the quality of the isotope values doesn't really have much to do with what the FTIR shows us. But that's just what we know until now. Maybe there are some changes when we finish the analysis. And so now for our environmental reconstruction, we can say that we have typical species of the Floresian land mammal age, also the extinct ones, and that we have for grassland, but with significant amounts of C3 plants, probably, yeah, grass and shrubs or trees. And yeah, sorry. Also, we probably have large water bodies, and yeah, close to the site is the Vaal River, so maybe that could have an impact, but also around the site there are some pans, so there could have been lakes in former times. And this is quite a contrast to the modern savanna biome we have at the place. And all in all, we have a minor but provable human impact. So yeah, that's what the environment could have looked like back then. And thank you for your attention.